Hello and welcome back. This module we're talking about oblique drawings. In the last video we covered some of the technicalities and the theory behind oblique drawings. In this video we're going to focus in and talk about plan obliques and elevation obliques and how they are used in architectural drawing. So let's compare these two drawing types. On the left, you have plan obliques, and here's an example of the same two same two buildings drawn in plan oblique style versus elevation oblique in the other one. First of all, you're going to orient the horizontal planes of the subject parallel to the picture plane. Those horizontal planes are now the ones shown in true size and shape. The vertical ones are foreshortened. And when we talked about you can choose the scale in plan obliques, it's the vertical dimension that you can choose the scale. If you're comparing a plan oblique to an isometric drawing, the one that we learned last week, they're going to look like they have a higher angle of view. Okay. And a major advantage of a plan oblique, can't even say it, plan oblique drawing is that you can start with the floor plan as your base drawing. Okay, and as architects, we love this because we typically already have a floor plan. All right, elevation obliques. Let's talk about this other type. In elevation obliques, you orient a vertical plane of your subject, which would be its side elevation, parallel to your picture plane. Okay, this particular vertical plane will be shown in true size and shape, and other parts of your object or your building will be foreshortened. Okay. When you're setting up an elevation oblique, you want to start with or select the longest or the most complex or the most significant face of your building, and that's going to be front and center. So let's go into a little bit more detail about plan obliques. To construct your plan oblique, you're going to start with your plan drawing and literally rotate it on a particular angle. Now, in hand drafting, which we're going to be drawing by hand, you typically rotate it either 45 degrees or 30-60 because that's what triangles you have, and those are easy to do. If you want to do this in a computer, you can do it to any angle you like. And notice, depending on which angle you choose, you're really choosing the view of your building, the three-dimensional view. Okay, once you have on your drawing, you've got your plan and you've got it rotated, you start projecting your vertical edges, your vertical lines and planes. Okay, you can project them out to their true lengths, or you can use a scale reduction to a half, 2/3, 3/4 of their true lengths. Okay, and I'm going to show you that in an example. So when you choose those angles and when you choose that vertical scale, which is going to give you your foreshortening, you really affect the overall appearance of your object, of your building, of your design. Okay, and here's an example of the same object, it's just a cube, all right, drawn at multiple angles and multiple scales or foreshortening. So we can see the difference that it really makes in this layout. So it looks like in this column here, we have our plan laid out at 30 degrees from the horizontal. Okay, in this column, they're laid out at 45 degrees, and at this column, they're laid out at 60 degrees. And kind of in the top row, we have 100% or 1 for our scale of the vertical lines. The next row has 3/4 or 75%, and the bottom one has 1/2 or 50%. Okay, and you can really see that if this truly is a cube, which I'm sure it is, the 100% vertical scale gives a little bit of exaggeration visually to that vertical dimension. And that's why many designers choose to reduce the scale in the vertical dimension. Let's talk about elevation obliques next. You're going to begin with an elevation view, which is a side view of the principal face of your subject, okay? The longest, the most significant, the most complex, right? So in this example, we have the same three-dimensional object, okay? It's, I don't know how to describe this object, but and these are two different elevation obliques. You can see that by choosing a different elevation face, a different side of the object, you very much give different emphasis to your portrayal of this object. Okay, so choose your elevation carefully. And then from significant points in your elevation view, in this case they've used the vertices, okay, you're going to project receding lines back at your chosen angle into the depth of the drawing. Okay, so with plan obliques, we started kind of at the bottom of our object and projected up. With elevation obliques, you're going to start with the front face of your object and project back into the depth of your drawing. So angles and foreshortening. In elevation obliques, we can also choose the angle at which we project those receding lines. Okay. In the plan oblique, we chose the angle at which the plan was sitting on our page and then projected vertically. Elevation obliques, your elevation is going to be true vertical. Okay. And then the receding lines will be projected at an angle. And you can choose that angle. And here's an illustration of the same object or same building projected at a 30 degree, a 45 degree, a 60 degree, and a 75 degree. So you can see that by choosing that angle, you're really choosing the three-dimensionality and the view angle that you're looking at that building. Okay. Next, you can also use some foreshortening techniques to adjust for any kind of length distortion. In the plan obliques, we scaled the vertical dimension. Okay. In the elevation obliques, you're going to scale that depth dimension instead. All right, so here's an illustration of this object at 1 or 100%, and here it is at 3/4%. All right, I have one more illustration of the same thing. And here it is right here. We can see that the object is 100%. Okay, here's at 3/4. Here's at 2/3. Okay, and the 100% often appears to us visually as exaggerated or overextended. Okay, and that's why many designers choose to foreshorten their oblique drawing. All right, in this video we talked about plan obliques and elevation obliques. Next, I'm going to give you a little demonstration of these techniques. Thanks, everyone.